Alright, so this question says to use the substitution u equals pi on 2 minus x. If we're going to do that, we have to really find out what du is in terms of dx. So we've got du being just negative dx. The other thing we need to know is what x is. So if we take this one and make x the subject, we get pi on 2 minus u. Okay, so we're going to use both of those and change the integral. So if I look at the integral now, it's equal to, if I want it in terms of du, I've got the x limits at the moment, so we make them u limits. So sub in 0 for x, we get pi on 2 minus 0, and then pi on 2, so pi on 2 minus pi on 2 is 0. Then if we look at, alright, so we've got du equals dx there, sorry, du equals negative dx. So if I have a negative in front, I can now put a du there, no problem. And the other thing is sine x, so now I'm making that sine, instead of x, that's pi on 2 minus x. And on the bottom, we've also got sine pi on 2 minus x cos, oops, plus cos pi on 2 minus x. Alright, there we go. So one of the things you can do is you can tip the limits upside down and get rid of that negative out the front. So just remember we sub in the top minus, then we sub in the bottom. So if there's already negative out the front, we can just tip that upside down. So now get rid of that negative. There's 90 minus x, we know are complementary relationships. So sine 90 minus x is the same as cos of x. So in this case, and what I should have been writing is u's, not x's. There we go. So x is equal to pi on 2 minus u, so they should be u's. So we're working in terms of u now, so that's cos u. Again, the complementary relationship to sine is cos, and the complementary of cos is sine. Alright, so remember we're trying to show, we're doing a show that. Now, we've got a nice integral there with u's. We can always change the letter, it doesn't have to be u. So we can change it back to x. So it's cos x on sine x plus cos x dx, and that's what we had to show. Alright, so once you have it in terms of u, it looks a little different to what it started, but really, if you look, the integral of sine x on sine x plus cos x is the same as the integral of cos x on sine x plus cos x, only if you're going between 0 and pi on 2, of course. That's all we've proven. Alright, so the second part there is by adding the two integrals. So we're adding this one and this one together. So we know that they're exactly the same, so really we're just saying two of the integrals equals, but we'll also add as we're instructed to do. And they're both between 0 and 2 pi, so I'm just going to put them together straight away. They're both on a denominator of sine x plus cos x. So if we add them together, we get a nice integral that is really just the integral of 1. And we know the integral of 1 is x. So between 0 and pi on 2, we get just pi on 2. So we've got two lots of the integrals is pi on 2, therefore one lot of the integral divided by 2 must be pi on 4. Alright,